So welcome back. This evening we're going to work with fractions, decimals, and percents. We're going to get into converting fractions, decimals, and percents. Remember, percent is that little symbol there, which means per 100 or hundredths. And don't forget, percent also can imply that dividing by 100, which we talked about. Dividing by 100 basically moves that decimal two places to the left. Of course, we have the word decimal. We know looking for that decimal point for a decimal. And a fraction, remember, that's just that numerator-denominator concept. So we have a top over a bottom kind of number. Let's just look at some examples here of what they're wanting to be done. For instance, let's change 90%. And what we want to do is we want to change that percent to a decimal. So since we're given a percent, we want to change that to a decimal. So percent to decimal is what we want to do here. And again, 90% means 90 over 100. That changed it to a fraction. We also know that to change a percent to a decimal, we just got to move that decimal two places to the left. So remember, we got that decimal point there at the end. It's got to slide two to the left. And that would end up being 0.90. And that meets the criteria of what percent means. Percent means per 100, so like 90 over 100 or 90 hundredths. Because remember, hundredths place goes two places past decimals, so we have 90 hundredths. So there's that concept. So that would be our answer to that problem. Now, here I have 452 thousandths. Remember, this is the tenths place, hundredths place, thousandths place. So this is 452 thousandths. And what we're asked to do is change this decimal to a percent. And remember, we just got to do the opposite now. So just move the decimal two places back to the right. And that gives me 45.2 and stick on that percent symbol. And that would be 45.2%. So here I have 25%, and I want to change that percent to a fraction. By definition, we know that percent means 25 out of 100. So I've achieved my goal of changing it to a fraction. But don't forget, they want those fractions in what we call lowest terms. So if there's a common divisor, we want to take that out. And we should recognize that these are both divisible by 25. So if I divide the numerator and that denominator by 25, that's going to allow me to reduce it. And remember, 25 over 25 is like saying 1. And since we're dividing by 1, it doesn't change the value of it. It just creates what we call, again, an equivalent fraction. So 25 does go into 25 one time, and 25 does go into 100 four times. So 25% would be the same thing as 1/4. So let's look at 3/4, and we want to change it to a percent. One of the strategies on this problem is I have 3/4, and what I can pick up on is to make a percent, I need 100 as a denominator. So if I look at this thing, is there a way to make that 4 turn into 100? Well, we should recognize that if I multiply 4 by 25, if I multiply by 25 there, that's going to create that 100 there. But remember, to keep an equivalent fraction, I would also have to multiply the numerator by that 25. So 4 times 25 is 100, 3 times 25 is 75, and I can now flip that into 75%. So I could actually just rename the fraction so that the denominator is 100, and then that falls into percent language. 75% means 75 out of 100. Another way to do it is I actually could change this fraction to a decimal. So I could go 3 being divided by 4. So I could divide that out. And again, we can use what we call that rain game. So the 3 goes in the garage. And we would say, well, does 4 go into 3? We don't see that happening. So there's where that decimal comes in. And how many 4s does it take to get 30? Let's see here. Let's count the multiples of 4. Before 8, 12, 16, 20, 24, 28, 32. So it looks like 32 is too big. 28 looks just right. 1, 2, 3, 4, 5, 6. So it took 7 4s to get there. So that 7 goes above the 0 because we're going 4 into 30. And my 4 times 7 would be 28, and my remainder would be then a 2. And since I got a remainder, we've got to continue on with our problem. So we add a 0 in, slide it into the problem, and we ask ourselves how many 4s go into 20. Well, there's 1, 2, 3, 4. It takes 5 4s to get a 20. And since that's even, it terminates into a decimal of 0.75. So 0.75, and remember to change a decimal to a percent, we can then change it to 75%. So when it asks to change a fraction to a percent, we could change a fraction to a decimal, then to a percent. We don't have to necessarily go straight to a fraction to a percent. But it is possible if I can change that denominator to 100. So looking at this 2/5, and I want to change that fraction to a percent. So again, I got this 2/5, and if I want to change it to a percent, my denominator's got to change to 100. So we decide how many 5s will it take to get 100. And maybe we'll recognize that 5 times 20 is going to be 100. Therefore, we have to multiply the top of the fraction by 20. And so we end up with 2 times 20, which is 40. So 5 times 20 is 100. 2 times 20 is 40. That 40 out of 100 can then be changed into 40%. So I've achieved my goal of changing a fraction to a percent. Don't forget, we also could use division. I could change a fraction to a decimal by using long division. So if I divide 5 into 2, so again, we talked about that rain game. The 2 goes in the garage, 5 goes in 2. Well, that's not happening. So we have to bring our decimal in, add a 0. So we bring our decimal up in the answer. And 5 does go into 20 4 times. So 4 times 5 is 20, my remainder is 0. And 0.4, I can move the decimal 2 places to the right. And that gives me my 40% as well. So remember, if you're changing a decimal to a percent, just slide the decimal 2 places to the right, stick on that percent symbol, and that represents your percentage. So 40% again. If I want to change 3 to a decimal to a percent, remember 3 is a decimal number. Don't forget that if you have a whole number, the decimal is always at the end. So for 3, don't forget we have 3.0. Now remember, to change a decimal to percent, you're essentially sliding the decimal 2 places to the right. So therefore the answer would have to be 300%. So 300% would be the same thing as the number 3. And that should make sense because 1 whole is like 100%. So if 1 whole is 100%, 2 wholes should be 200%, and 3 wholes should then be 300%. So 3 would be the same thing as 300%. Those would be equivalent expressions. This is in a decimal form, and this is in a percent form. So hopefully this will help you model fractions, decimals, and percents. Stay tuned.